Hello, my name is Sam, and you are watching an episode of Expressive Syntax. This is the show where together we learn about programming. Um, let's see, today we're going to be doing more koans. Koans are a way to, practice a language, learn a language. We're going to be doing Ruby koans. Last week we did, what did we do last week? Oh, like conditionals, control flow. This week we're going to be doing something. It looks like the task for this week is sort of a little programming problem that kind of incorporates a bunch of stuff that we've seen already. So I'm excited. It'll be good. So this is where we left off. About triangle project, line 8. So let's check that out. Let's dive right in. About triangle project. So I was looking at this a little bit before I started recording, and like trying to figure out what this wanted us to do. And it looks like we're going to be making, okay, so there's this comment that says you need to write the triangle method in the file triangle.rb, and then the triangle method will return one of these three symbols, either equilateral, isosceles, or scalene. I'm not sure if I'm saying that right. Scalene triangle, depending on what the inputs are, what kind of parameters we give it. So let's first make triangle.rb, I guess. Required.triangle. Yeah, let's just do that. I guess I can make it anywhere here in this folder. Triangle.rb. Yeah. So like we've done a bunch of this stuff before, kind of in one-off koans, but this is our first time kind of combining a bunch of stuff. And this is the cool thing about programming. You learn kind of a bunch of tools like Lego blocks, and the fun is when you actually get to combine them and build something. So this is a small example, I think, but we'll get to use a bunch of stuff that we've learned about, which is exciting. So let's see. We're going to define a method called triangle. We use the def keyword, triangle, and it looks like it takes 3 parameters. What should we call these? A, B, C? Side A, side B, and side C? Because I think that's what this is representing. So like, it's an equilateral triangle if all 3 sides have the same length. But we can get away for now. We can make the test pass just by returning. We can make the first test pass just by returning equilateral. Let's just try that and see if it works. See if we're on the right track. What? Expected equilateral to equal nil? What did I do wrong? Did I not save something? I feel like I'm I sense frustration. Do not be afraid to ask for help. Yeah, if you see me making a mistake and it's obvious to you what I did wrong, post in the chat. Be like, hey Sam, you're making an obvious mistake. And I will turn on the chat going on my phone so I can see if people actually post. One sec. Okay. Actually, let me turn this so it doesn't turn off. Bum, bum. Nope, not Twitter. Twitch. How do I turn off like sleep mode on my phone? Does anybody know how to do that? Display and brightness maybe? Ooh, auto lock, there we go. 5 minutes, I want to make it never, just for now. Just while we're coding. Okay. Ah, cool. Okay, let's get back to the coding. That was a good distraction. What did I do? Okay. Yeah, I was looking this stuff up. Scaling triangle. One where all three sides have different lengths. Okay. So we're returning. So the test is failing on line 8, and it says expected equilateral to equal nil. Does that mean we're returning nil on our method? Am I reading this right? Line 8. Equilateral to equal nil. Do I need an explicit return? I don't see why I would. Let's try it. Okay. Are we even getting in here? Hello? Okay, so it seems like I don't see it printing hello anywhere, so we're not getting into this method. So what is that? We require triangle, and we call triangle. Did I save this in the right place? Oh, this is the problem. We already had a triangle.rb, and we were expected to write code there. And we made our own instead. Okay, so figured it out. Let's get rid of this. That makes sense. Sure, move to trash. That's fine. Yeah, so it was failing because it was looking at this method, and this method returns nil. Yeah. Oh, and look at this. This is all the information that I was trying to look up earlier. Equilateral, if all sides are equal. Isosceles, if exactly 2 sides are equal. Scaling, if no sides are equal. Right. Okay. So back to where we were. Let's try just returning equilateral and seeing if that passes the first test. Just the first test. Expected isosceles to equal equilateral. Great. Okay. So let's make this actually smart, because we don't want to return equilateral for everything. We want it to return equilateral for just the triangles that are equilateral, that have the same sides. So let's make a conditional here. If A equals B and B equals C, then they're equilateral. Isosceles. Else return isosceles. Will that do it? That's like 20. Yeah. Okay. So now, right, so this is not actually very smart. We need to make it distinguish between isosceles and scaling triangles. So so we know that they're not, at this point we know that they're not all the same. but if A equals B, or B equals C, or C equals A. We got to get all those possibilities. Then it's isosceles. Otherwise, it is scaling. Does that make sense? So we're kind of using the transitive property here, right? Is that the right word? Because if A is equal to B and B is equal to C, then we also know that A is equal to C because of the transitive property. So therefore, they're all three the same, and it's an equilateral triangle. And here, we only need one of these to be true. Only two of the sides need to be equal for it to be isosceles. But if none of them are equal, then it's scaling. Right? Let's run the test and see if that passes. Yeah, we're on to about exceptions. Cool. That didn't take very long. You want to learn about exceptions? Let's dive into exceptions. About exceptions. I feel like this is an area that I could afford to be better at, learn more about how they work in Ruby. So this is good. Good to practice. All right. So we have our class, mySpecialError, and it's a runtime error. Okay. So we're setting up this error. Exceptions inherit from exception. Oh, interesting. I've never seen this ancestors method before. Huh. I wonder, I'm a little bit curious what this does for other types of objects, right? Because we're calling it on the mySpecialError class. I mean, other types of classes. So we're calling it on this class. I want to see what it does for, like, I don't know, string maybe. String dot ancestors. Oh, interesting. It gives us like a hierarchy of classes. So string is a comparable. It's also an object. It's also a basic object and a kernel. I don't know what a kernel is. That makes sense. Oh, interesting. What about fixnum dot ancestors? Oh, interesting. Fixnum is an integer. It's also a numeric and a comparable and an object and a kernel and a basic object. It seems like most objects would have at least object and basic object, I would think. I don't know what kernel is, but maybe that too? Huh. And then like other ancestors depending on whether it's a comparable or numeric, right? Yeah. Oh, that's interesting. Ancestors. I'm gonna remember this. This seems like a super useful tool to see what the kind of class hierarchy is. All right. So special error. Let's call. Ooh, we can call it on runtime error and see what the ancestors of that are. Right? So if we do runtime error dot ancestors, we get runtime error, standard error, exception object, kernel, basic object. So I'm guessing, okay, so the 0th element is going to be mySpecialError. The first one is going to be runtime error, right? Second is standard error. And then exception. and then object. Am I getting this right? Object. Let's try it. Gotta exit this though. Line 10. Oh, no, I messed something up. Okay. Uninitialized constant about exceptions. Standard error. It doesn't know about standard error? The runtime error inherited from standard error. Oh, I misspelled it. That's why. Standard error. Oops. Let's try that. Yeah, so now we're on line 32. Okay, so before we move on to the next thing, ancestors, the reason this is cool is because we're getting a bunch of extra functionality from all of these classes in the ancestors hierarchy, right? Like, exception will have a bunch of functionality and methods, as will standard error and runtime error, and we're getting all that kind of for free just by inheriting from runtime error. It's power of object-oriented programming, power of inheritance. Okay. Rescue clause. Okay, cool. So result equals nil. And then we have a begin. And we fail inside the begin, and then we rescue the error. And set result equals to exception handled. So interestingly, exceptions, you could think of exceptions as another kind of control flow, like deciding what code gets executed or not, depending on whether an error happens or not. Well, yeah, let's keep walking through it. Yeah, we only get to this bit of code because we failed inside the begin, right? So, control flow. I don't usually think of it that way, but maybe it's helpful. It is helpful, certainly, to know how this works and what code gets run when. Oh, this only gets run if we fail. But if we don't fail, this doesn't happen. Okay. Assert result. So result equals exception handled because we do fail inside the beginning. Exception handled. It's handled. Handled. Let's see, did we get that right? 25, cool. Assert equal. You know what, I'm going to make my font size. I always forget to do this. I should do this right at the beginning. Make my font size bigger so you can all follow along at home and see exactly what's going on. Cool. Exception is a standard error. Should be a standard error. True. So excuse me. We fail. We rescue a standard error. So it is definitely a standard error. And it's also a runtime error. Should be a runtime error. Oh, interesting. Even though we're only rescuing standard errors, the error is both a standard error and a runtime error, so it rescues both. Is that true? Apparently that is true. Okay. So we say we rescue standard error, but because the exception that we're throwing is both types, a runtime error and a standard error, exception is both a standard error and runtime error. Yeah, cool. Okay. Assert runtime error.ancestors include standard error. Runtime error is a subclass of standard error. Okay, yeah, that seems reasonable. That's just basically what we were just that I was just saying, right? Assert equal exception.message. Ooh, okay. So what is the message? I don't know. Let's look at what this says. Exception from is equal oops. Oh, so when we fail, we pass the failure message. Oops. Okay. Oops. Cool. 43. Okay, so what's going on here? Test raise a particular error. So like before, we have result equals nil. Excuse me. Oh, gross. Raise and fail are synonymous. Okay. So we can either call fail or raise. Oh, we can also specify what kind of error we're raising, as well as the message. And we rescue my special error. The result is exception handled. So what is the result? Since we raise it and rescue it, the result will be exception handled. Unsurprisingly. Exception handled. And the message is the one that we pass, as we learned. Cool. Break. 57. Cool. On to line 57. Ensure clause. Okay. This is interesting. This is not a feature that I use very often, but I think it's really good to know about. This is the kind of thing they'll ask you about in job interviews to see how well you know your Ruby. Okay. So result equals nil, starts out as nil. We begin with a fail oops like before, we rescued standard error like before, and we ensure result equals always run. So we fail. Ensure happens whether or not we fail. So result equals always run. Right? Line 63. Yeah, so I just want to confirm that for myself. If we don't fail, do we also end up on line 63? Yeah, cool. So this, anything inside ensure always happens. Sometimes we must know about the unknown. Asserting an error is raised. A do end is a block. A topic to explore more later. Okay, so we haven't. They're just saying we haven't gotten to do end yet, apparently. But we can test in our test. We can say assert raise, and we can have our test raise an error, and this only passes if we get the error, right? Like it's really useful to be able to test those kind of edge conditions where things break. So useful to be able to say, oh, this should get an error. So let's see, what will make this pass? If we put in my special error, I believe that passes. Oh, yeah, okay, cool. So we finished about exceptions. We learned about how exceptions work. Exceptions are very useful to understand. You'll see them often, and it's useful to know what to do with them. When I was learning to code, I didn't raise exceptions very much. It felt uncomfortable. Mostly, I was like trying to rescue other people's exceptions. But as I've gotten better at programming, the more often I'll be like, you know what, this is an error condition. We should raise an error here. Your input was invalid, or we have some unexpected result. Let's raise an error. Yeah, cool. So where are we now? About triangle project? 2. Oh, there's 2 of these triangle projects. So we're on to line 10 of this. Ah, okay. So we're adding to our triangle method, apparently. You need to write the triangle method in the file triangle.rb. Required triangle RB like before. Excuse me. About triangle project 2. The first assignment did not talk about how to handle errors. Let's handle that part now. Sweet. Test illegal triangles, throw exceptions. Yeah, this is exactly what it's talking about. If your users pass in something that is invalid, you should throw an exception. We can get tips if we want. Let's see if we can do this without tips. So assert raise triangle error. So if we pass in 0, 0, 0, that's invalid because you can't have a triangle where one of the sides has length 0. So let's go over to triangle and catch that exception, or raise that exception, I mean. So if, let's see, A equals 0, or B equals 0, or C equals 0, then if any of them are equal to 0, then we want to raise that exception. Oops. Wondering if there's a better way to do this. More like if any of them are equal to 0. No, this is fine. This is fine. Then what kind of error? We want to raise a triangle error. So has this been, do we have something called triangle error already? Let's just try doing raise triangle error. This might not work. It might be like, what are you talking about? What is a triangle error? Yeah, exception triangle error. Expected but uninitialized constant triangle error was raised. Doesn't know what triangle error is. Okay, so let's look at about exceptions and look at how we make a new kind of exception. That's what we want to do. So here, we'll define a class and we'll call it triangle error, and we want to raise one of these. We don't want to raise, right? We want to raise triangle error.new, and we'll say sides can't be 0. Oh, what is this? Oh my. Oh, we got a syntax error? Oh no, what did I do wrong? Superclass mismatch. What? Oh, missing parentheses? Maybe that's the problem. I would not be surprised if this fixes it. I'd also be surprised if, I would also not be surprised if it doesn't fix it. Yeah, it didn't fix it. Okay. So, okay. Let's look at our about exceptions examples. So we have error.new. We pass in a message. Isn't that what we're doing? What's the problem? All right, let's just comment things out one at a time and just figure out. No, okay. So it's not this that's causing the problem. It's apparently this that's causing the problem. Huh. Yeah. So we have some sort of I thought this would be fine. I thought we could define a class and also define a method that's like just separate from the class. But apparently it's not working. What am I doing wrong? Just wanna... Yeah, you're not really giving me any help. Superclass mismatch or class triangle error is a type error. Triangle line 34. Oh my gosh, I did it again. I assumed that I had to create something that they had created for me. So here we go. Triangle error inherits from standard error. Blah. Okay. And they were helping. They told me exactly what the problem was, what line it was on. If I just read the error and looked, I would have seen it was this. Okay, great. So I bet we're passing that test now, right? Triangle project, do line 10. No? Triangle error expected, but uninitialized constant. Oh, I misspelled it? Oh my goodness. Oh my goodness. Copy and paste, so I can't make a typo here. Boom. Triangle, not triangle? Triangle? Oh geez. Okay. Hey, we're on to line 11. Oh my goodness. That was painful. Alright. So here we go. Nope, wrong thing. I'm going to close this. Yeah, okay, line 11. So what is wrong with this triangle? Oh, negative length? If any of them are negative, that's not allowed. Okay. So if A is, we just want to change all these to less than or equal to, right? If it's less than or equal to 0, then it's not allowed. And that should work. Yeah, line 12, on to the next one. Ooh, interesting. So this is not allowed because A plus B is less than C. Similarly, A plus C is equal to B. Both of these are not allowed. Okay, so let's start with that first scenario. Triangle. Here we go. So if... Ooh, I have an idea. I thought of a way we could make this a little bit nicer. Let's break these out into methods and give them names so that it's clear what's going on here. if sides less than, and then we'll have, ooh, is this really saving me effort? Side less than 0. I have to, oh, because this isn't a class, it's just a single method, I have to pass in A, B, and C, which maybe, maybe I don't want to do. I could refactor it into a class. But no, it's looking for just a single method. I'd have to refactor all the tests too. All right, let's just keep going. Let's do it the simple way first. Simple way first, and then maybe we could think about making things better. So what is the situation that we're handling? Right. A plus B is less than C. If A plus B is less than C, or actually this should be less than or equal to, or A plus C is less than or equal to B, or what combination did I not get? C plus B. C plus B are less than or equal to A. Then we want to do this raise an exception thing. Okay, triangle error, and we'll give it a different message that helps explain what they did wrong. How do we explain this in a way that's simple and understandable? Sides added together can't be longer than the third. That's pretty good. Please make it more sentence-like, and try that. About iteration. Ooh, exciting. Cool. Well, this has been about triangles, where we kind of did a bunch of stuff. We combined, control flow with these if statements, and conditionals, truthiness, mathiness with these statements, and also practice raising exceptions. That's cool. That was some good practice. I really wish they had been more clear about what they had put there for you and what they hadn't. I also, to be fair, I should have read the error message. I wish I had read the error message. That would have been better. All right, cool. So that's been about triangles and about exceptions. I think I'll call this episode about exceptions, right? Because that was the main new thing that we learned. And next time, yeah, exciting. We're going to be learning about iteration. Let's take a little preview before I sign off. About iteration. Each break iterating over lists of things. Cool. All right, so that'll be for next time. My name is Sam. You've been watching ExpressiveSyntax. If you're watching this on Twitch, please subscribe. If you're watching this on YouTube, hit the like button. Consider subscribing. That would be great. I stream every Thursday at 7:30. Hope to see you again next week. Bye.